Welcome students, this is Professor P.P. Kulkarni. Today we are going to learn chapter number 5, Fundamentals of ENC System. In this chapter we will understand what is mean by a numerically controlled system, and the contents of the chapters are elements of ENC manufacturing system, concept of work zero and machine zero, then different types of ENC system we will learn, structure of ENC system, then different drives which are used in ENC system and their devices also. Detailed steps in ENC manufacturing system, advantages of ENC manufacturing system, disadvantages of ENC manufacturing system, and then nowadays mostly used system that is called as a flexible manufacturing system. Elements of that flexible manufacturing system we will see, then application of FMS that we will see and at the last we will learn merits and demerits of flexible manufacturing system. So let us see one by one. First of all, understand what is ENC system. A numerical control system is a system in which actions are controlled by direct insertion of numerical data at some point. This system must automatically interpret at least some portion of this data. In numerical control system, data is inserted and that data is in a form of numbers, letters and symbols. So we are going to learn part program in chapter number 8, and there we will see how these numbers, letters and symbols used in ENC systems. Today part programs can be generated directly by using CAD database ENC softwares. So for example, Delcam and Mastercams are softwares which are used for writing a part program or generating a part program automatically. Now let us see elements of ENC manufacturing system. There are three elements basically. First one is a program of instruction that is called as a part program. Second one is a machine control unit that controls the processes in manufacturing, and third one is the processing equipment, or you can call it as a tooling device. It performs all manufacturing operations. All these three elements, the first one is a part program, second one is a control machine control unit, and third one is a processing unit. All these three these are interconnected to each other, and by using these three elements we are going to manufacture a component in ENC system. Now let us understand what is a part program. A part program is a series of coded instructions which are required to produce a part. Now let us see here N10, G01, X 5.0, Y 2.5, F15. These letters, numbers and symbols are given. These are just one form for writing a part program. The coded instructions are composed of letters, numbers and symbols, and these are arranged in a sequence. Now let us see what is this N10. It is a sequence number. When you write a part program, N indicates line number of that part program. G01, it is a linear interpolation mode, but G is called G01, or G codes are called as a preparatory codes in part programming. Then X, Y, these are the coordinates. Also there is a Z coordinates that is used in the drilling operation. F indicates feed rate. It is shown here F15. So 15 is a value of feed rate and its unit is a inch per minute. Sometimes the units may change, it may be millimeter per minute. Now let us see, in part program there is a role of punched tape. So what is this punched tape? It is a medium to write a part program in ENC system. Its length is approximately 1 inch. NC machine system coding uses alphabet characters, numericals and other special symbols in part program, and this part program is coded on a punch tape. So whenever you write a part program for NC system, you need a punch tape. So this punch tape uses a punch card. Its a picture is shown in this figure. This is a punch card, you can see here. Then there are some pictures of punch tape. There are different types of punch tape. There are also advanced punch tape that you can see. This diagram shows a punch tape reader. It is just like old days we were using tape recorders. These are the rollers, and over these rollers punch tape is mounted, and when these rollers rolls, then punch tape is read by a machine control unit, and accordingly it performs the operations. So in this photo, Fanuc it is shown, FANUC. This Fanuc is a name of a controller, and this right one and the left one both are the rollers over which punch tape is mounted. Therefore it is called as a punch tape reader. Now let us see a very important control unit that is called as a machine control unit in NC manufacturing system. So machine control unit is the heart of numerical control system. What is its function? It reads coded instructions one by one in a sequence. It decode coded instructions. It provide decoded information to control loops of the machine axis of a motion. It also control machine tool operations, and there are some advanced tape which are used to repeat a punched tape again and again, so that part program will be repeated again and again. Also there are some codes used in part program to repeat a part program whenever you manufacture a component. Let us see the next slide. Machine control unit, it has basically two components. First one is a data processing unit, and second one is a control group unit. So DPU, what is its function? Data processing units, it reads a program, it decodes it, and it processes the information and it passes to CLU. Once again I read, data processing unit, it reads a part program, it decodes the part program, means it releases instructions given in the part program, then it processes the information which is given in part program, then it passes the information to CLU. Now what is this CLU? CLU is a control loop unit. It converts the information to control signals. CLU, it converts the information to control signals, and it drives the mechanism which receives a feedback about position and velocity of the tool, and it instructs data processing unit to read new instructions. Means CLU works for implementing all the instructions given by DPU. Once again I repeat, CLU works for implementing all the instructions given by DPU. At the last, CLU it instructs DPU to read the new instructions which is coded in a part program. So both are very important in machine control unit. Now let us see the next bit of this chapter. It is a concept of work 0 and machine 0. Both are very important to write a part program in the machine. So this is a diagram of a lathe machine. Here you can see this diagram. Work 0 it is shown, and machine 0 it is shown here. Now let us understand what is the work 0 and machine 0. I have shown this diagram by zooming it to just understand what is the location of work 0 and what is location of machine 0. Now you see here, machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0, it is not a fixed point. You can see this diagram. Machine 0 is not a fixed point. It is shown at a location here, but it may be at another location in a machine. So it is not a fixed point. But if you see a work 0 normally sets at a front face and at the center of a job. So you can see this diagram. Work 0, it is normally set at front face and center of the workpiece. So while writing a part program, we take offset in a machine, in a CNC machine we take offset, and this offset is taken with respect to a work 0, and we write a part program. So once again I repeat, what is a machine 0? Machine 0 is a floating point in a space having a measure normally to accommodate a length of machine and maximum transverse length to each axis. So machine 0, it is not a fixed point, it is a floating point, and it may be at any place in a machine. And work 0, it is normally set at front face and at center of the job. So work 0 is important to write a part program. Sometimes in the examination we are asked to write a part program, but their work 0 is not defined, so we have to assume this work 0. So work 0 you can take at the front face at the center of the job, or you can take at any space on the work. So work 0 you must assume on the surface of workpiece itself. So work 0 is important to write a part program. It is a reference positions to define a coordinate in a part program. Now let us see a types of NC system, that is a classification of NC system. First one is it is based on a motion type, point to point NC system, then straight cut NC system, then contouring NC system. Next is the based on positioning system, incremental NC system, absolute NC system. Then on the basis of control system, open loop control system and closed loop control system. And next one depends on power supply, electric power supply, hydraulic power supply or pneumatic power supply. So let us understand these types of NC system one by one. So first one is a point to point NC system, PTP. So in this point to point NC system, so coordinates or workpiece moves from one point to another point in a linear motion. You can see this diagram. So these points indicates motion direction of workpiece. Each point has coordinates and tool moves from one point to another point to third to fourth to fifth. So these points are nothing but you can call it as a holes which are obtained by using a drilling tool, and this drilling tool drills the workpiece is mounted on the table. So tool moves from point to point. So whenever you go for the drilling operation, you need a point to point NC system. One example I will tell you, convex drilling, it needs a point to point NC system. Now let us see a straight cut NC system. Straight cut NC system is mostly used for milling operations. You can see this figure. In this figure, this is a milling tool, and there is a workpiece which is to be milled, and this spindle moves along the surface of the workpiece and you can mill the component. So you can see here the direction of milling tool in which it moves, that is shown in this diagram. So this tool moves from This location